Hey class, it's Mr. Clausen here. Just wanted to go over the Newton's laws of force just a little bit before your test tomorrow. There's a little bit more this time than there was with projectile motion, so just bear with me, but I'll go through this the best I can to hopefully help you get prepared. So let's start off. There's three laws of motion when it comes to force. The first one is an object in motion will stay in motion. Object at rest will stay at rest unless acted on by a net external force. So here's the key idea on this one. It's the idea that that net force is what causes an object to change its motion. Now, not all objects want to change their motion the same. The more mass you have, the more inertia you're going to have, and the more inertia you have, the more you're going to resist your motion. We're doing a lot of demos with that this week. Hopefully that idea has gotten to you. This is what we did our lab on. A lot of you chose to do the simulation instead, but it comes down to Newton's second law. It says an object's acceleration is directly proportional to the net force applied, and it is inversely proportional to the object's mass. So what this means is the more force you have, the more acceleration, and the more mass you have, the less acceleration. They're written mathematically here. You put those together, and you get Newton's second law right there, which is force is equal mass times acceleration. Newton's third law, a lot of people know it. It says for every action force, there's an equal and opposite reaction force. So these come in action-reaction pairs. Remember, the things to remember when it comes to action-reaction pairs is that they act on different objects. Okay? So you push on the wall pushes on you. Those forces are acting on different things. One force is acting on you, and one force is acting on the wall. So just keep that in mind. All right, so we'll apply those here, but let's just go through what is a force. A force is the ability to cause a change in an object's motion. It can be a push or a pull, and since direction matters, it's a vector quantity. Now, there's a bunch of different types of forces. Remember, we did this little example here. We talked about, okay, you got all these forces acting on the book. It can get very difficult to keep it all straight. The different forces we have there are the force of gravity, or you would call this weight. You can have the applied force, and that's simply just any push or pull that you or another object might be doing on the object in question. The normal force is a specific force. It's the force that's coming up from the surface. And then we have the force of friction. Now, friction, we're going to study more next unit, but this unit, it's all just been about whichever way motion is going, friction is opposing it in the other direction. So this could be air resistance or sliding on the table altogether. All right, so like I said, there's a lot of forces that can act on something. So what we do is we bring up this idea of what we call a net force. And the idea behind a net force is that if you were to take all the forces and add them together or combine them together, you could replace them with a single net force. So the object would act just like it was with all the forces acting on it, or just that one single force would do it. Now the net force can be calculated one of two ways. One is Newton's second law deals with the net force, so it says the net force is equal to the object's mass times acceleration. Or you can go to the definition or the idea of it, which is to say that the net force is equal to all the different forces acting on an object. So here I said force 1 plus force 2 plus however many forces there might be. Now the important thing to realize when it comes to forces, when you add them together, they are vectors, so the same rule of vector addition holds true. So the verticals go with the verticals and the horizontals go with the horizontals. But usually we haven't gotten too complicated with that yet. All right, so that brings us up to a couple different scenarios. In this scenario over on the left in the blue, we have two forces acting in opposite directions. They happen to be the same size. And the question is, what is the net force? But since the two forces are the same size, but one is positive and one is negative, the forces ended up canceling each other out, and we have no net force. Over on the side with the right, we have one force is bigger than the other. And so even though they're acting against each other, the side of the 805 ends up being a little bit bigger, and that wins out, giving us a net force to the right. Now there's two terms we use to describe what's going on here. One is what we call balanced, and this is when the net force is equal to 0. And what this happens to do is it means that there is no acceleration and the motion stays constant. Another way to think about this is if there's no acceleration, it's the velocity that's staying constant. So keep that in mind. You can have balanced forces and still be moving. It just means you're moving at a constant velocity. Unbalanced forces, on the other hand, say that the net force is not equal to 0. The acceleration is greater than 0, and therefore the object is going to change its motion. So this is anytime you have acceleration, you know that one of the forces is going to be bigger than the other. All right, let's go now into the different types of problems I could ask you coming up in this next sort of test. So the problems we're going to commonly see are this one here where it says you're going to ask you to calculate the weight of the mass. And the way to remember this is we had our weight ain't mass lab, and what we learned from that is the word weight really just means force of gravity. So force is calculated as mass times acceleration. To calculate the force of gravity, you just use the same formula, but this time you use the specific acceleration g, which is the acceleration due to gravity. Just a reminder, g is 9.8 meters per second every second, so 9.8 meters per second squared. Keep that in mind. If I ask for the weight, you're going to use the mass in 9.8. If I ask you for the mass, well, then you just put your weight in over on that side. So remember, force of gravity is the object's weight. Another one I'll ask you to do is draw a free body diagram. So there might be like some written scenario, and I'll ask you to draw on all the forces. Here's the important thing to remember. All of these objects, unless otherwise stated, are taking place on planet Earth, so always draw in the force of gravity and use the object's mass, or if it was in newtons, you'd use its force and just fill in the value for that. If the object's sitting on a table, which a lot of times it will be, if it's sitting on the ground, there's going to be the normal or support force. A lot of our problems right now have those two forces being the same size. Then I'll add in some other things here. You know, you might have an applied force over here, and then maybe a little bit of friction or something like that. So there's going to be problems where you have to draw the free body or force diagram from it. Using the free body diagram, I often then ask you to calculate the net force or the acceleration, and either I'll give you the object's acceleration or I'll give you the net force, and I'll ask you to find the other one. Remember, there's two ways to find net force. A lot of the times with the pictures, all you're going to do is just add the forces together. So in this case, gravity and the normal force would cancel out, but the force applied and the force of friction would actually have to be, in this case, since they're going different directions, you'd subtract off the force of friction. You could use this to calculate the net force, and then once you knew the net force, if you knew the mass of the object, you could use that idea to help you figure out what the acceleration would be. So if you knew the mass and the net force, you could find acceleration. And the same process works the other way. If I give you the acceleration, then you can use its mass to find the net force. Using the net force, you can plug that in up here, and whichever one of these forces I end up giving you, you could find the other one with those equations. All right, sometimes we've had some issues here when it comes to the vertical net force or elevator type problems. It's pretty much the same thing as what we were doing up above. There's only a couple things I can ask you. Either what I can do is I can give you all the forces acting on the object, and from that what you can do is you can then figure out what is the net force, and then I will ask you to find the acceleration. Or what I can do is I can give you the acceleration and maybe one of the forces, so maybe I give you its mass or I give you the force of gravity. From that, you would be able to quickly find out the net force and then use the idea that net force is supposed to be equal to all the forces added together, and you would be able to find the unknown force. So like in this case, it's asking for what would be the force of air resistance. The important thing to remember on this is whichever forces are going down the negative direction is really important. Okay, the last type of problem that we've been seeing a lot of the time so far are these action-reaction type problems. And what we got going on there is the key is, like, so here's the example of me shooting a little ping pong ball launcher. And remember, which object feels the greater force? The answer is we both feel the same force. The force of Mr. Clausen on the ball is going to be the same as the force of the ball on Mr. Clausen. Now, we both experience different accelerations because I have a very large mass and the ball has a very small mass, and so we end up feeling different accelerations. My big mass gives me a little acceleration, and the ball's little mass gives it a big acceleration. Now, the way I typically ask these types of questions is like we have over here. I'll give you the information about one object. So in this one, it's the ping pong ball. We know that it's got a very small mass and it goes out at a very big acceleration. I'll then ask you to figure out what is, say, my acceleration on the other side. Now I'll give you my mass. So what you do is you use the idea here that mass times acceleration equals force, and mass times acceleration equals force. Since two forces end up being the same, what you can do is you could calculate this through and figure out what the force is in the middle, which in this case it would be 100. But since both sides end up being equal to each other, right? So they're all equal to the same thing. this middle step of calculating the force isn't necessarily needed unless you actually were asked what is the force that's produced. And I do that from time to time to help you, guide you along in the process. So this video is getting a bit long. I just wanted to go through it with you. Hopefully this is a brief overview and it helps clarify things a little bit here for you. Good luck. I will be there tomorrow. And yeah, we'll see you later.